In this video, we're going to talk about using density as a conversion factor. So density is the ratio of the mass of an object to the volume occupied by that same object. So the equation looks like this. So density equals mass divided by volume. Now, which units your mass and volume are in will depend on what type of substance you have. And these aren't the only units for density. As long as you have a mass over a volume, it's considered a density. But these units here are kind of the most commonly used for each state of matter. So if you have a solid, grams per centimeter cubed is typically the units. Liquids, grams per milliliter. Gases, grams per liter. Now, this doesn't look like a conversion factor the way it's written as an equation. And you've probably done density calculations at some point in your life, but probably never really thought about it as a conversion factor. But we do have a ratio of two numbers here. So that in itself is a conversion factor. So if we know mass of something and its density, we can solve for volume. Or if we know volume and its density, we can solve for mass. So that is a conversion. So let's look at an example and how we could set this up. So we have a mineral that has a mass of 17.8 grams and a volume of 2.3 centimeters cubed. So in this case, we're just calculating density. This isn't a conversion yet. So we're going to put the mass, 17.8 grams, divided by the volume, 2.35 centimeters cubed, and plug that in. You come up with 7.57446. Think about sig figs. We have 3 in the mass, 3 in the volume, so our answer is going to have 3. 4 is the first one to go away, so we'll round down. So 7.57 units are grams per centimeter cubed. Okay. In this example, we have a mass of our, we want to know the mass. If we know the volume is 49.6 milliliters, and it has a density of 0.85 grams per milliliter. So the way we can think about this density is that for every 0.85 grams, I have 1 milliliter. So there's my equivalency. So my conversion factors are going to be 0.85 grams per 1 milliliter or 1 milliliter per 0.85 grams. So which one we use depends on where we're starting. So we're given the 49.6 milliliters. Milliliters are on top, so they need to go on the bottom of the conversion. Grams is what I can relate that to on the top. So I'm using this conversion. So 0.85 grams divided by 1 milliliter. So that's going to be the 49.6 times 0.85 is 42.16. Units are grams. For sig figs, we have 2 in the density, 3 in the original volume. This one is exact. So we've got 2 is our lowest number of sig figs, so our answer is going to need 2, so 42 grams would be the final answer.